to check it. Okay. If you want to, yeah. Yeah. Right. Anything you can fit on that card. All right, here we go. Number one. We talked about this in the book review that we did on Friday. So hopefully this will be familiar to you. I think the book review on Friday was 2.3. This one is 2.7. So if this number line is wrapped around the unit circle, show where the point 2.7 maps onto the line. So I'm going to say that 1 would go right about to there. 2 would go to there. I'm just, again, I did this. Oh, I just threw that string away today. I'm just taking this right here and making it 2.7 long. It's just a piece of paper. And then I'm going to wrap that around the circle, and I'm going to put a dot where that ends. Okay? Does that make sense? That's all I'm doing. Okay? So, well, I will, I mean, obviously there's going to be a range of answers. If you're, yeah, it's going to be an estimate. If you're in the first, third, or fourth quadrants, obviously not correct. That's pretty clear. But I'm not going to be like, oh, no, it should be right there, and you put it right there, so it's wrong. Okay? Just have to be in the ballpark. So just take, visualize a piece of paper or a piece of string that's 2.7 units tall, and then wrap that around the circle, and the dot is the answer. Yeah, okay?
Well, why can't the dot be
Because that's only 2, and this says x equals 2.7, so I had to go up to here, and then I kind of estimated that that would end up there. Okay? So 1, 1, 2, 2.7. Yeah, I think you're right, and we're about to find that out. Okay, so then it says on the figure in problem 1, sketch an angle of 2.7 radians in standard position. Well, if this dot is where 2.7 is, then this angle is 2.7 radians. Okay, so the orange is the answer to number 2. The red is the answer to number 1. Yep, because we just wrapped 2.7 radiuses of the circle onto it. Mylena, do you need to go to the in-house room? I don't appreciate your attitude today. Holding. Yeah.
So what if on the test, will you understand uncounted dark in this?
Yeah, yeah. Yeah, Gus just asked, how will I know the difference between your answer number 1 and your answer number 2? Your answer number 1 is just the point. Your answer number 2 is the physical angle. All right, let's see now how we did. Let's take 2.7 radians and figure out how many degrees that is. What do I, okay, good. So to change radians into degrees, I multiply by 180 over pi. So do not make the mistake of just waiting until everybody else does this. You should physically do this on the calculator yourself. Make sure you get the same answer. Mylena? Okay. So let's see how close we were there. Oh, yeah, that's dumb, huh? Yeah, I just got that. 157. Oh yeah, Kai, you're right. We only went like 135 there. So yeah, so we would need to have that way more down around to the left. But that's okay. That's okay. Close enough. Yeah. 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 So we were given 2.6 radians, change it into degrees. All right, number 4.
Wait, 3? What did you say about 3? You just said it from answer
Oh, and oh yeah, right. And this would be, this is in quadrant 2, right? Yeah, so technically for number 3, that's why it says, I guess, no calculator. It just wants you to show this part right here, but not actually figure out what the answer is. But, you know, calculators are fine. And then that's in quadrant 2. Okay, find the exact radian measure of 30 degrees. So what do I multiply? Awesome. So what does that reduce to? What does that reduce to? What does that reduce to? Pi over 6. We want the exact, so we're just reducing the fraction. We're leaving pi in the answer, okay? When it says exact, do not type pi into the calculator. Yeah? It doesn't matter because we haven't taken the sine or the cosine or the tangent of anything, okay? Mylena, in the future, we get the calculator before class starts so that you're not a distraction to the class. Thank you. For that, yes. Yes. Okay, now we're going the other way. Find the degree measure of negative 2 pi over 3 radians. So I'm going to multiply by 180 over pi. So when I do that, the pi's cancel. And then how many times does 3 go into 180? 60. And 60 times negative 2 is negative 120. So the pi's canceled, right? And then I went 180 divided by 3 is 60. And 60 divided by 2, or times 2 is 120. And then, yeah. Uh-huh. Okay, next one. Draw a sketch illustrating the angle inverse cosine of negative 3/5. All right, cosine is what over what? Adjacent over hypotenuse. So this is going to be the adjacent side. This is going to be the hypotenuse. If the adjacent side is negative, which direction do I have to go? This way. Good. So I'm going to go 1, 2, 3 this way. And then not up 5. I'm going to make a hypotenuse of 5. So this is negative 3. This is 5. Good. We don't need to know that, but that is good that you know that it's a 3, 4, 5 right triangle. So there is a sketch illustrating the, oh, sorry, then the angle is this angle right there. That's because you're like the worst student in this class. Hang on just a second. I know. Pretty awesome. Yeah. Yeah. Show it to your parents. Get me fired. Quickly. Like tonight. So I don't have to come to school tomorrow. What did you say, Sky? Right. No. Okay. I see what you're saying. This way would be a negative angle. Okay. Inverse cosine. That means find the angle. Okay? So anytime there's a little negative 1 on there, that means find the angle that goes with those sides. Yes. You have to make that drawing. Okay? You're not actually finding the measure of that angle. You're just making the drawing that shows that you know. Yeah, that's, yeah. I mean, it might be sine. The numbers might be different. Okay, so you asked to explain how to do this. So the adjacent side. Okay, so, okay. Yeah, that'd be a great thing to put on your note card, but this is, it's super important. That's how. Do you know SOHCAHTOA? Okay, this is what you have to know. SOHCAHTOA. I'm about to explain. Ready? So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is, there you go. Oh, okay, so this is the angle is always goes with the x-axis. So the adjacent side is the one that's touching the angle, and the opposite is the one that's across from it. Basically, the adjacent is going to be x, and the opposite is going to be y. Okay? Yes. The adjacent side is the x-axis, and the opposite side is the y-axis. Okay? Do you want to, should we just like make up another one? You're good? This picture is the answer, yeah. Okay.
Opposite of cosine?
Yes. All right, number 7. The inverse cosine negative 3 over 5 is one value of the arc cosine of negative 3 over 5. On your sketch in problem 6, show another angle equal to that. Yes? She went this squared minus this squared and then took the square root. But you don't need to, I mean, I guess you should know how to do that. She just used the Pythagorean theorem. So she knew a squared plus b squared equals c squared, right? So she went negative 3 squared plus c squared equals 5 squared. And if you solve that, you get b equals 4. Okay? All right, where is another triangle that I can draw that has an adjacent side equal to negative 3 and a hypotenuse 5? In the third quadrant. Good. So I can go 1, 2, 3 that way, and then instead of going up, I could go down. So this would still be a negative 3 and a 5. And now the angle that I would be looking for is that one right there. The big one. Yeah, from the positive x-axis to the hypotenuse. Okay. Yeah. Counterclockwise? If you're solving an equation, yeah. If you, I guess you could go minus 2 pi n. You want to go the other way around? Yeah. Okay. Okay. Good luck. Arc cosine is inverse cosine. Those are the same thing. Yeah. Arc cosine. So those two things are the same thing.
How is that?
Not really, no. That's why I have to have this right close to my...
How is that angle equal to the...
Because if I asked you to find the cosine of this angle, you would say it is the adjacent side, which is negative 3, divided by the hypotenuse, which is 5. If I asked you to find the cosine of this angle, you would say that's the adjacent side, which is negative 3, divided by the hypotenuse, which is 5. Comes out to be the same both times. They see the board. With my voice, yeah. So you see everything you need, yeah. Like, why do you guys come to class? That's the question. Okay, so were you, Cody, looking at number 8?
Yeah, I was just trying
Okay. Okay, so the general solution for arc cosine or inverse, right, the general solution for arc cosine negative 3/5, in terms of, yeah, we're going to skip that one. Yeah, that's the plus 2 pi n thingy. Yeah. So, because cosine is a specific one, and arc cosine is all of them. Okay. Okay, number 9. Sketch the graph of the parent trigonometric function y equals sine of theta. Show scales on both axes. So how far up or down should we go? 1 and -1. Good. What should my things be on the x-axis? Nope. There you go. 2 pi, because that's one cycle. So that means halfway is pi over 2, and in between there is 3 pi over 2. Okay, so where does the sine function start? Nope. Cosine starts at 1, sine starts at 0. And then it goes up, back through the middle, down, and back through the middle again.
It starts at 0, oh my god, that's funny.
Perfect. Once again.
I'm going to try number 10, not the one.
Okay. Nailed it. Oh. Yeah, we're not messing with tangents.
And I wish you were doing this as notes, so like I just kind of have the presentation on my phone.
Okay, number 10. Sketch the graph of the parent circular function y equals cosine of x. Whoa. Okay, how far up and down? How far up and down on the y-axis should I go for cosine? 1 and -1, good. And then what should I make the scale on the in Senior's room? 2 pi again. Yeah, I almost feel like I need to go over there and see.
No, column.
So same things as before. The difference is cosine starts where? Starts above, up at top. What? Yeah, back and front, both sides. Okay, so 1, and then it goes through pi over 2, and then it goes to -1, and then through 3 pi over 2, and then back up again.
Who's making the noise?
Why can you what?
Not remember anything.
Because I was mean to you at the beginning of class, and I totally screwed up your whole... So I apologize, I was just kidding. You're a terrific student. I missed it. What'd you do? That's my Lena.
I was watching the NFL Red Zone the other day, and
All right, number 11. Sketch the graph of y equals 4 plus 3 cosine pi over 8 times x minus 5. So this is a little bit trickier. I got rid of it because I realized that the whole graph is going to be above the x-axis. So right in the middle. Yeah. Okay, you need to focus on the math and not the football. Okay, what is the middle line? What is the sinusoidal axis for this? How far up did it get moved? Yep, good. It's at 4. I'm going to go 1, 2, 3, 4. So at 1, 2, 3, 4, I'm going to put a dotted line for the middle. What's the amplitude? So, yep, one of them at 7 and one of them at 1. What's the period? Nope. B is pi over 8, which will help us find the period. Good, 16. So I'm going to go all the way out to, well, I guess I got to be careful. How far to the right or left has the graph been shifted? 5. So I'm really going to start my graph at 5. So if my period is 16, how far do I have to go? Good. There, she's back. Halfway in between 5 and 21 is? Yep. And halfway in between 5 and 13 is? And halfway in between 13 and 21 is? Close. Close. 17. Okay, where does the cosine graph start? Right, 5, 7 at the top. And then it is going to go through the sinusoidal axis at 9, bottom out at 13, go back up at 17 again, and then up to 21. So it looks like that. Mm-hmm. Right. I think if you were to get a B plus or whatever on the test tomorrow, that would really help your grade a lot. Yeah. Maybe. Possibly. Eric? How did I go from what? The axes or the graph itself? Okay. I took 20. Right. Because I know that the period is 16. So I took 5 and I added 16 onto it and got 21. And then 16 divided by 4 is 4, so then I went up by 4 from 5 up to 21. L. Okay, number 12, draw a sketch representing a circle of radius 5 feet. Sketch a central angle subtending an arc of 7 feet. The practice test is not graded. So this is 5 feet. Where would 7 feet be if this is 5 feet? Like, how far around the circle should I go to make it be 7 feet? 90 degrees-ish? Somewhere right there? Okay, so let's call that 7 feet. And so we want to find the measure of that angle. Here's how it goes. S equals r theta. The arc length equals the radius. I was trying to remember if we've done this before or not. We haven't done this? Okay. How about this? It's just 7 divided by 5.
Cool. Point their point.
What is happening? That's not the same place we were.
Oh, you guys said we didn't do this one, so let's not do that. You know that 1 radian is 1 radius of the circle, right? So if this is 5, then 1 radian is going to be right there if I went just 5. So there's 1. And then to get to 7, I have 2 more. So 2 out of 5 is 1.4. Yeah, right, exactly. The radius is your base unit. That's exactly right. So how many radiuses the question really is, how many radiuses can I fit on this 7-foot arc? And it's 1.4. Okay? Maybe. Yeah, I think we are, because we didn't do the things with like pulleys and stuff. Yeah. Okay, 13, find the degree measure of 3.5 radians. What do I multiply by? What do I multiply by?
Pi over one, or 180 over
180 over pi.
You guys want to use my answer.
Now we're actually going to do the multiplication because it didn't say exact. So go 3.5 times 180 divided by pi.
So they give you notes there.
I'm just writing it off the wall. I got
200.53.
200.53.
Okay, easy peasy. I turned the heat down, sorry about that. Okay, plot the graph of y equals secant of x using the window shown. That's going to be extra credit. So I will go through it with you guys, but you don't have to know this. Secant goes with cosine. So the way I would graph this is I would start by making a cosine graph. And then 1 over that would look like this. I think we spent one short day on this, just seeing the general shape of the graph. This is extra credit, so no, you don't have to do this. But that's what this is, yeah. This would also be extra credit. It says plot the graph of y equals cotangent of x. So tangent of x goes like this. Cotangent of x is 1 over that graph. So it's flipped upside down. So the red is tangent. And then cotangent goes these away. Ooh, nothing. You should be like, oh, that's so pretty. The orange is the cotangent and the red is the tangent.
So there's secant, cotangent, and...
Can I just like clear this out and drop this to the equivalent?
Yes.
That's all.
Yes.
So it's secant, cotangent, and the other one is just inverse of tangent. Remember there's like 3 or 4.
Yeah, secant, cotangent, and cosecant.
Okay, that's the one. That's cotangent right there.
Yeah.
And that's extra credit.
Yeah, so don't worry about that. Yep. Okay, number 17. For this sinusoid, write the particular equation using they're forcing us against our will to use cosine. So the bottom of this is 2, the top is 10. Donde está el middle? Very nice. Didn't realize you spoke Spanish so well. So the middle is 6 because 10 plus 2 is 12. Divided by 2 is 6. What's the amplitude? 4. And then they said cosine, so fine, whatever. Cosine it is. What is the period of this? Huh, that's a little tricky, isn't it? What do you think this high point is at? What x coordinate? That's 3.
That is 27.
3 to 27. Okay, I accept that. So the period is 24. So that means b equals 2 pi over 24, which is pi over 12. And then that's times x minus 3, because it's 3 to the right. I sure can. Minus 3 because the top of the graph is 3 to the right of the y-axis.
I have a dream that if we got together, it would be so millions of dollars.
Yeah, I mean, he'd have a lot of money to give, you can get whatever you want from him, I guess. Austin?
So, when, you know how it's kind of like both estimated, not
Yeah,
exact,
right.
on this side? Well, we have like a range.
Yeah. I guess what would be best to defend yourself would be to write down what you think those are so I can know where you got that number from. Okay. All right, almost there. Write the particular equation of the sinusoid in problem 17 using the sine function. Rats. Y equals, what's the sinusoidal axis? How far up? Okay, 6 plus, good, 4. Now we're going to go sine pi over 12 because all of that stuff is the same. The only thing that's different is now we want to start in the middle here. Yeah. Let's go with 10. Okay.
It goes all the way to 30, like
10 to 35.
Okay. Like that?
I'll go to 9. Yes, sir, no, because the freaking base is
It's not exact, yeah. Yeah, it's not quite at 10. We will. Money back guarantee. Yep. Huh? Exactly. All the money that you have paid me personally, I will return to you. All right, next one. Earth and Mars problem, 19 to 23. The distance between Earth and Mars is a periodic function of time. Assume that the function is sinusoidal, and this particular equation is that. X is in days after today, and Y is in millions of miles. The figure shows the graph of this function. Identify the horizontal dilation. How much has it been shrunk or shrinked or whatever? Okay, let's come back to that. What's the period?
It's the same. Pi is equal 1.
Nope.
Well, I don't
What did you put 2 pi over to get pi over 390?
How, can I, what are these
780. Okay. What is the amplitude? How far above or below the middle line did they go? Oh, never mind. The amplitude's on the graph. What's the amplitude?
93.
93. What's the phase displacement?
Isn't that on the, it's all in the equation?
Yep, it's all in the equation. What's
141.
140? What's the vertical translation?
141.
141.
But then what's the horizontal dilation?
Don't worry about it.
Is there one?
There is one, but we don't need to worry about it.
what was the usual? Forget about it.
Okay, we all right with that?
Yeah.
All right, based on the equation, on what day will Earth and Mars first be closest to each other? So when will this happen right here? No, super easy. Super easy. This x value right here is what? 140, because it got moved 140 to the right. Okay? The period is 780, so that means this next x value right here is going to be what? What's 140 plus 780? 920. Okay. So the low point is going to be right in between those two things. What's halfway in between 140 and 920? Close. 530. You have to add them together and divide by 2. So this middle point right here is going to be 530. Okay? The low point, to summarize again, the low point is halfway in between the two high points. Okay? You know the first high point happens at 140 because of this equation. You know the next high point happens at 920 because the period is 780, right? That means it takes 780 days for it to complete one cycle. So halfway in between there is 530. So this would be at day 530. What's going to happen if we don't finish? You think I am some sort of a rookie? There are intervals of time when Earth and Mars are within 100 million miles of each other. Estimate on the given graph the first such time interval. So when are they within 100 million miles of each other? Between what 2 days? And they just said estimate on the graph. So what x value does that look like? 400. What x value does that one look like? Maybe a little bit short of 7. Can I get like a 680? Okay, so I would say between days 400 and 680.
What's horizontal dilation again?
Horizontal dilation is how much it's been shrunk or stretched. We don't really talk very much about that, so I'm not gonna worry about that. No.
And vertical translation?
How much it got moved up, so that's where the sinusoidal axis is. All right, find the time interval in problem 21 numerically. Okay, so what was the equation? Okay, so we got to take that and set it equal to 100.
There's no room to do that. There isn't.
There's no room to do that? Okay. So I don't know, what do you want me to do?
Get rid of it.
What? Oh, is there room after number 23? There's room for number 23. Okay, 22 and 23 are the same. 22, they want us to use our grapher. So that means just graph it and see where they cross. But we're not going to do that because I don't want you guys on Desmos. So we just do this as number 23. Okay, here we go. What else?
I'll just cross it out and
Yeah. So you're basically skipping 22 and we're doing 23. Okay? Okay, and what do I do to solve this?
So first, you have to minus 141.
Okay, so 93 cosine pi over 390 x minus 140 equals negative 41. Then
Wait. Slow down.
speed up.
I mean,
Yes, you can. Now what? Yeah. Okay, tell me what you get when you divide negative 41 by 93. Negative 0.44. All right. Now what? Here's the fun part. Yeah, second cosine of negative 0.44. So pi over 390 x minus 140 equals plus or minus I don't know what that is. 2.02 plus 2 pi n times by 390. What's 390 times 2.02? Plus or minus 787.8 plus 780 pi n. Okay. Now what? Divide by pi. So the pi's cancel from here. X minus 140 equals, what's 787.8 divided by pi? plus or minus 250.76. Okay. Thank you. And then here the pi's just cancel, so it's plus 780 n. And then if I add 140 to that, we're only going to do the positive ones. We're not going to go into negative time. So I'm going to ignore the negative 250 and just add 140 onto positive 250. So that's 390.76 plus 780 n. So if you plug in 0 for n, what do you get? 390.76. Which, if you go back here, we estimated between days 400, so we were close, okay? Oh, I guess I would need the negative to plug in 1 to get the smaller one. So, never mind, we'll just take the starting point there, okay? All right? Yeah, that would be the exact one. We estimated around 400, but it looks like it's more like 390, okay?